Let's look at another example. So consider the following data ages in a class. So we have some 20-year-old students, some 21-year-old students, 22, 23, 24, and then one student who's 65. We're going to find the mean, median, the mode of the above data, and we're going to consider if there are any outliers. And then maybe which measure of central tendency best describes a typical entry for this data set. Now notice that the data is already in order for us, so it just makes it a little bit easier. If your data is not in order, I do recommend putting it in order. Just again, it makes it easier. You need to do that to find the median anyway. So the first thing I'm going to do is find the mean. So I have 1, 2, 3, 4, 5, 6 20s. Actually, just going to make a little note for myself here. I have 1, 2, 3, 4 21s. 1, 2, 3 22s. 1, 2, 3, 4 23s. 2 24s and a 65. Now, when we're adding these up for the mean, what we're going to do is add each of these data points and then divide by the total. Oh, this should be a 1, 2, 3. So let's say I have 6, 10, 13, 17, 18, 19, 20 students. So what I could do is I could write these out, 20 plus 20 plus 20 plus 20 plus 20 if I want to. Or I know I have 6 of them, so you can kind of take a shortcut and do 20 times 6, right? Because I'm going to write that 26 times, plus 21 times 4, plus 22 times 3, plus 23 times 4, 1, 2, 3, 4, yep, plus 24 times 2, plus 65. And I'm going to go ahead and divide that by the 20. So let's see what we get. All right, so I have 20 times 6, double checking this, 21 times 4, 22 times 3. Oh, I missed my 23. 23 times 4, and then 24 times 2 and 65. I get 475. I'm going to divide that by 20, and I get 23.75. And again, we can round this. So if you want to round to the nearest whole, you can. Usually we tend to round to 1 decimal place more than our data set, again, in the real world, but obviously my math, I may have you round a specific way. So I'm just going to round to 1 decimal place here. Now my median is my middle number, so I can just find this by counting in. So 1, 2, 3, 4, 5. I'm just taking off 1 on each end so I can find that middle value. Now remember, I have an even number, so I don't have an exact middle. I'm going to have 2 of them. So my median will be the average of these 2. So 21.5. And then finally, my mode. Now the mode is the number that occurs with the highest frequency. If I look through here, I do see that 20 occurs 6 times, which is the most often, right? The other numbers only occur 4, 3, 2, or 1 time. So my mode is 20. Now, are there any outliers? Oh, excuse me. Now we will have a formal way to define an outlier or define like the calculation for an outlier in section 2.5 later. But I think this one's pretty clear that our outlier here would be the 65. So the other ages for students are all in their early 20s, and I have 1 student who's 65. So that's very different from the group. So there's definitely an outlier here, and that would be the student who is 65 for this particular class, right? So let's look at our data set and see, well, which measure of central tendency, so one of these 3, for this example, best describes the data. Now, the first one is the mode, and that's 20. And I know I have a lot of 20s here, but 20 is the lowest age in the class. So I don't really think that 20 would be the best answer to describe a normal entry, right? It kind of seems to be somewhere in the middle, right? So 20 is a little bit low here, I think. My median is 21.5. So that's my middle value in this case. Now this one I think looks really good. You can see it's like pretty much right in the middle of the data, right? Most people are in their early 20s. So we have a lot of people in their 20s, 21, 22, few in 23, 24, there's only a couple, right? So most people are on the early side of their 20s. So that 21.5 seems like a good value. And then my mean here is 23.8. Now, if I look, that mean is like way up here, right? It's almost at the end of my data set. What's happened is it's getting pulled by that 65. So this is a little bit high, right? If I look at most people in the class, that about 24 years old is very high. Most students are younger than that, right? So in this particular example, I would say the median is our best our best central tendency, because it just more accurately describes the data. And again, the reason is because that 65 is really pulling the mean. So normally we like the mean, but because of outliers, it can get affected very easily. Whereas in this case, 21.5 years old seems to be a better value for what the overall class age is. And then on the next page here, again, they kind of have a nice visual. I just copied this from your text. And it says the mean takes every entry into account, but it is influenced by the outlier 65. The median also takes every entry into account, although, you're really just choosing one or two values to use here. So because of that, it's not affected by the outlier. The mode exists, but it does not appear to be representative of a typical entry. So the median in this case, again, tends to be the best. Here they have a graphical representation of the data to help you see which central tendency measure is the best here. And you have a histogram. And what you can see here is, they did it with a class width of 1. So everybody who's 20, there were 6 of them. 21, there were 4. Then I see 3, 4, 2. And then here's the person who's a 65. And you can see there's a huge gap here in the middle, which shows us that we do really have an outlier there. Now, if you look at your values, notice how the mode is hanging pretty well to the left. The mean is really far to the right, whereas the median in this case does seem to be in the center of the overall data. So if we kind of exclude this outlier, that median is really right in the middle, and that's what we want with a measure of central tendency. We want that middle point. So in this particular case, that median there really is the best option, right? It's right in the middle of the data. I know I have one data point here to the side, but it's so different that for the majority of data, that median right there is what we're looking for. And now we're going to do the same thing, but removing 65 from the data set and see what happens. So if we do that same calculation, so I'm going to use all those same data points, but in this case, what's going to happen is I'm going to take that 65 away. So when I go back and do my calculation for the mean, I'm going to add all those values up, but I'm not going to add the 65. So what's going to happen is it's going to take my sum, and instead I'm going to have only 410. But be careful, I'm not dividing by 20 this time, I'm dividing by 19. Right, because I only have 19 data points now. And I get a mean of about 21.6. Now my mode isn't going to change, so that 20 still occurs the most frequently, so that mode doesn't change here, and we just have to recalculate the median. So if I go back to the page before, sorry guys. Oh, here we go. So I go back to the page before here, and I try to calculate my center this time with the median. Remember, 65 is not going to be included. So I'm going to ignore that 65. I'm going to count in towards the middle. Now I have only 19 points this time, so I should have a nice true middle here. So I'm going to use yellow here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I see that 21 right in the center this time. So my new median, there we go, is that 21. And now you can see the median and the mean are much closer to each other because we don't have that outlier pulling the mean away. And actually, you'll see this, the more kind of centralized your data is, the more together it is, the more it's symmetric, so it kind of looks all even. You're going to see that the mean and the median are going to end up being this closer to being the same, right? So the more like balanced your data is and close to the center, then you're going to see that these values get closer together.